Have you ever wondered if there's a population that hasn't evolved over generations and what conditions cause it to be that way? A population that is not evolving is at Hardy-Weinberg equilibrium. Here are the 5 conditions. There should be no mutation, random mating, no natural selection, a large population, and no gene flow. Here is a population of bacteria. It divides and one of the bacterium has a mutation to resist antibiotics. An antibiotic is added and the mutated bacterium is the one to survive and reproduce. This population evolved and can't be at Hardy-Weinberg equilibrium. The second condition is random mating. A member of the population can't choose who it wants to mate with based off of certain traits it's looking for. If you're a bird and looking for something to eat, which peppered moth would be easier for you to spot? Probably the lighter one. So if the original population of peppered moths was half light and half dark, what do you think would happen to the allele frequencies after 50 years? The frequency of dark moths would outnumber the lighter moths because they're the ones with a higher survival rate and more likely to reproduce. This is why the Hardy-Weinberg equilibrium states there is no natural selection. So the fourth principle of the Hardy-Weinberg equilibrium is that the population must be large. This is because small populations have a higher chance of genetic drift, which is the unpredictable fluctuations of the allele frequencies. For example, here I have a small population, so there's a higher chance of genetic drift when a flood occurs. Now the population is going to decrease because some of the organisms will die. For example, this black one has died. Now the allele frequencies of this population has changed due to the flood. Now there's only 2 white organisms and 1 black one. This is why the Hardy-Weinberg equilibrium states that the population must be large. Here are 2 populations. This is the dominant red population and this is the recessive yellow population. If one of the members of the red population decides to mate with a yellow member as it's immigrating, its offspring will be red. So this is why the Hardy-Weinberg equilibrium states that there should be no gene flow. Okay, so based on the problem, we know that q squared equals 0.25. So q must equal 0.5. So to find p, we use the formula p plus q equals 1. So that means p is 0.5, just like q. So to find the homozygous dominant frequency, we do p squared, which is 0.25. And to find the heterozygous frequency, we do 2pq, which ends up to be 0.5.